Hello students, welcome to Distinction Learning Platform, and on this platform you find expansion to difficult topics, you find the revisions, you find tests, quizzes, a lot of stuff. So before we begin our lesson, make sure that you subscribe so that you can be updated with all upcoming videos. To make the story short, let us begin. Okay, so in this lesson we're talking about cell injury. Basically this is for preclinical student, and this is under general pathology. Okay, and remember that everything that we're talking about, all the concept that we're talking about, it is Robin based. Okay, so we are talking about cell injury. What is cell injury? Cell injury basically is damage made to the cell because it was exposed to noxious stimuli or injurious stimuli. Remember that also stress stimuli can also lead to cell injury. Why? Because that stress stimuli, maybe it was progressive, severe, leading to what? Cell injury. Okay, so in this lesson we are talking about irreversible cell injury, but just to recap you, remember that there are two types of cell injury. There is reversible cell injury that we talked about in the previous video. Make sure that you watch it so that you're updated. The second type is irreversible cell injury. What is irreversible cell injury? Basically, this is a type of cell injury where a cell can't go back to the normal state of maintaining its homeostasis. Okay, I remember that there are some causes of irreversible cell injury. Remember that we talked about the causes of cell injury. Those same causes of cell injury can lead to irreversible cell injury. So what are we saying under irreversible cell injury? We're saying that it's a type of damage that is made to the cell that is irreversible. So we are saying damage which is irreversible. So damage that is irreversible, which is made to the cell. Okay, what else are we supposed to know? There are two types of irreversible cell injury. Okay, there are two types of irreversible injury. The first one is what we call necrosis. Okay, the one that we are going to be talking about in this video. And what is the second one? The second one is what we call apoptosis. Okay, the second one is what we call apoptosis. Okay, the second one is apoptosis. Remember that what is necrosis? Necrosis basically is a type of irreversible cell injury, or a type of cell death which is unregulated. And remember that necrosis is always a pathological process. It causes inflammatory response or an inflammation. Okay, then apoptosis is always regulated. No wonder apoptosis, sometimes it can be physiological and sometimes can be pathological. But don't worry, we'll talk about apoptosis in the next video. Okay, so what are we saying here? So we are saying this is a type of irreversible cell injury which is what? Unregulated. Okay, and the apoptosis is what? It is always what? Regulated. So we'll talk about that. So remember that if something that is regulated, it is programmed. So apoptosis is a programmed type of cell death. Okay, so now since we know the two types of irreversible cell injury, now let's go deeper into one type of cell death, which is necrosis. Okay, we'll talk about necrosis, all the types of necrosis that we'll talk about. Okay, we'll talk about all of them. So now let's talk about necrosis in detail. So what is necrosis? Basically, we know that necrosis is what? It's a type of cell death that is unregulated. If something that is unregulated, it can cause what we call inflammation. So what point can we put there? Okay, so let us put something important here. Okay, so we are saying type of cell death that is unregulated. If it is unregulated, what can it cause? Causes what? Inflammation. Okay, what other important point that I talked about? It is what? Always a pathological process. Okay, so now let me explain something here. So to go into details, if you look at the inflammation, inflammation basically you're talking about activation of like the immune system, activation of immune system, producing a lot of things, cytokines, so things that we talk about in inflammation video. Okay, now the question is, why is necrosis causing inflammation but apoptosis is not causing inflammation? Why? Because there is something that is there. If something is not regulated, basically it is an irregulated type of cell death. So meaning that the cell membrane of the cell that is undergoing necrosis, they're going to be what? Disrupted. If the cell membranes are disrupted, the cell is going to like leak out something. The cellular content is going to be leaking out cellular content, and they'll go into the what? Extracellular fluid. If they go into the extracellular fluid, what are they going to cause? Now they're going to start activating white blood cells that are surrounding that cell. Then if the white blood cells are what activated, they'll start producing what we call cytokines and other substances that are injurious, okay, activating the inflammatory response or the immune system. So basically that is it, why a cell that is undergoing necrosis is always what? An inflammation. Now, why is it also always a pathological process? Because a pathological process is something that is unexpected. Basically, if you look at a physiological process, it's something that is regulated, which is normal. Okay, but under necrosis, the reason why it's always pathological because it's not regulated, it's unregulated. That's why it will never be a physiological, unlike apoptosis. Okay, so since we've talked about that, the major thing about necrosis, now how can you differentiate necrosis from apoptosis? So the thing that we use under that are what we call morphological features of necrosis. So make sure that you know the morphological features of necrosis so that you can differentiate it from apoptosis. Okay? So what are those morphological features that you can see? If you look at the nucleus, I mean, let us start with the cytoplasm. So what can you see if you look at the cytoplasm? What can you see? So if you look at the cytoplasm, there is always increase in eosinophilia. Okay? Under cytoplasm, there is what increase is eosinophilia. So what does that mean? So that is just a staining thing. So if you look at the cytoplasm, why is it causing increase in eosinophilia? Why? Because if you look at necrosis, basically the proteins inside the cytoplasm, they are going to be denatured. Also, if you look at the nucleus, it's also going to undergo what we call nuclear changes that we'll talk about next year. So if that happens, mean that it's going to lose basophilia. The nucleus is going to lose its basophilia type of appearance. Then if it loses that, basically it's going to look like it's going to be like the staining thing, or the way it's going to look, it will resemble like eosinophils. Okay, so that's eosinophilia. Okay, so those are the causes why a cell under cytoplasm is going to have increase in eosinophilia. That's a staining thing. If you stain, it's going to look like eosinophils. Okay, what else? If you look at the nuclear, now let's talk about the nuclear changes. So what are those nuclear changes that you're going to see? Very, very important part. So nuclear changes that you're going to see. What is the first thing? The first thing that you're going to observe is what? The pycnosis. Okay? What's the first nuclear change that you're going to observe? Pycnosis. So that's the first nuclear chain that you are going to see. That is pycnosis. What is pycnosis? Pycnosis basically is what? Basically that's the shrinkage of the what? Of the nucleus. The nucleus are decreasing in size like that. Then it's undergoing what we call pycnosis. So what are we saying? Under pycnosis, we are saying nuclear size is going to what? Decrease. So size of the nucleus. Okay, the size of the nucleus is going to decrease. That is pycnosis. What else? Okay, let's talk about the karyolysis. Okay, so karyolysis basically the nucleus now start fading like that. Okay, So the nucleus is fading like that, meaning that it is disintegrating like that. Okay. So what is karyolysis? Karyolysis is what? That's fading of the nucleus. The nucleus is fading of the nucleus. What else? There is also another last one. The last one, which is karyolysis. So now, karyolysis is what? Fading of the nucleus. Fading and the breaking down the nucleus is one of the two different things. Okay. So karyolysis now, the nucleus is undergoing what we call like fragmentation, meaning that it is breaking down into smaller parts. So basically, this one undergoing what? So karyolysis is what? The nucleus is now what? Disintegrating into what is smaller fragments. So what is that? Breaking down of what? Of the nucleus. So what are the three nuclear changes that we observe? Pycnosis. What is pycnosis? Pycnosis, the shrinkage of the nucleus. What is karyolysis? Karyolysis is just a fading of the nucleus. What else? The last one is what? Karyolysis. Karyolysis is what? Just the disintegration of what? The nucleus into smaller fragments. Okay, that is what? Karyolysis. So those are the nuclear changes. What is the cytoplasmic change that you can see? Cytoplasmic change that you can see is just the staining. If you stain the cytoplasm of the cell that has undergone necrosis, it's going to stain what? It's going to increase eosinophilia. Okay. So now, since we are done with just the introduction to necrosis, now let's talk about the patterns of necrosis or types of necrosis. Patterns or types of necrosis. Just these are that's the same things. Okay. So what are those types of necrosis? So these types, see, they are basically is under morphology. What you can see. So what you can see due to different causes, then it will differ. Okay. So these types of necrosis, basically these are morphological types of necrosis. Okay. They help you to what? To see the cause of what? The cause of necrosis. Okay. Okay, let's start with the first one, coagulative necrosis. Okay, what is coagulative necrosis? Coagulative necrosis is a type of necrosis where the outline or the architecture of the organ is what? Preserved for at least a few days. So what am I saying? So this type of necrosis is what? The organ or the outline of the organ is what? Preserved. Basically, if you look at its morphology, it will just look normal. Okay. But after just some few days, then now, then it will show that okay, there is a severe damage to the organ or to these cells. Okay. So what are we saying? Under coagulative necrosis is what? Most common type of necrosis. Okay, where what? Where the outline is preserved. So here we are saying outline is what? Outline of an organ is preserved. The outline of an organ is preserved at least for what? Few days. Make sure that you understand that. Okay. Now the question is, what can cause this type of coagulative necrosis? What can cause that? Basically, remember that it will be just one common cause. What is that? We know that is the ischemia. Okay. What could cause coagulative necrosis? Is what? Ischemia. What is ischemia? Remember, ischemia is what? Ischemia is just a decreased flow of blood to an organ. What is ischemia? If there is decrease in the what? In the flow of blood to an organ is what we call ischemia. Okay. Now, what is really causing that decreased amount of blood that is going to an organ? It is because of what? Obstruction. Okay, obstruction of what? Blood vessels. So what I'm saying is what could really cause ischemia is what? Obstruction of what? Blood vessels. Okay. So what can cause that is what? Obstruction of what? Blood vessels. That is the real cause of what? Ischemia. Okay. Now let's go to mechanism of what? Mechanism of coagulative necrosis. Why do you think it take like coagulative necrosis? The organ will look normal for a few days. What is that mechanism? Why is it like that? Okay, the mechanism is very interesting. Coagulative necrosis, since it is caused by what? Ischemia, which is lack of what? There is obstruction to blood vessels. Basically, an organ is not receiving what? Much oxygen. If an organ is not receiving much oxygen, what will happen? Enzymes and what? Proteins will be what? Denatured. If that happens, enzymes are the one that destroys what? An organ. If they are denatured, basically the organ is going to what? To be preserved. The outline of an organ is going to be preserved. Although necrosis is happening, but there are no enzymes that are what? Killing the what? The cell. Okay, so what are we saying? The mechanism is what? Denaturing of what? Enzymes and what? Coagulating what? Proteins. Or coagulation of proteins. If there is coagulation of proteins and coagulation of enzymes inside the cell or basically of an organ, then basically what will happen is that the outline is going to be preserved at least for some few days. That's the reason why there is that preservation. Okay, now what are the organs? So the last important point is here. Okay, since we know ischemia is caused by obstruction of blood vessels. Okay, so now let us leave space for that. So now the question is, what are the organs involved in coagulative necrosis? Very important part. So all organs can be involved, but make sure that you know the exception. What is the exception? The brain. Okay, the brain doesn't undergo coagulative necrosis, but it will undergo the other type of necrosis that we'll talk about. Okay, so except the brain, all the solid organs, they can undergo what? Coagulative what? Necrosis. So what are we saying? All solid organs except the brain. Okay, what are those solid organs? We are talking about the heart, we are talking about the spleen, we are talking about the limbs, we are talking about the kidneys, a lot of organs, but except the brain. The brain can't undergo coagulative necrosis. Boom, boom, boom. We are done with what? Coagulative necrosis. Then what else are we supposed to talk about? Let's talk about liquefactive necrosis. What is liquefactive necrosis? That's from the word liquefactive. So from the word liquid, basically, it's a type of necrosis whereby there will be what? If necrosis happens, then there will be production of what? A liquid or a viscous mass. Okay, a mass that contains what? A liquid. So now the question is, what can cause that? Okay, what can cause that? So before we go into any details, what is liquefactive necrosis? We are saying there is always what? There is a type of necrosis where there is always what? There is always a liquid viscous what? Mass. Always under liquefactive necrosis. Okay, then the question is, what can cause that viscous mass? Okay, what can cause that? Remember, what are the causes? So here I'll talk about two causes. The first one is what? The common one, we know that is ischemia. So don't even rush. Now you're saying, ischemia can be caused by coagulative necrosis, but it is also here. But the major difference is that if ischemia happen in the what? To the central nervous system or to the brain. Okay, so what is ischemia? Remember, just to remind you, ischemia is what? The decrease in blood flow to the what? To the organ. But if that decrease, or there is an obstruction to the blood vessels in the what? In the central nervous system, it's not going to cause what? Coagulative necrosis. It will cause what? Liquefactive necrosis. Okay, so basically that is the first cause. What else? Okay, also infection. What else? Suppurative infection. Suppurative infection. Okay, suppurative infection. So infection can also cause what? Can also cause refractive necrosis. Okay. Now the question is, okay, we already know the organ that's going to be involved here is the what? The brain, on the brain. Here, that's simple. The only the organ that can be involved in the refractive necrosis, basically, just know that it's a brain. Okay. Now the question is, what is the mechanism? What can cause this viscous mass? Here is not causing that, but what can cause that? Okay. So there are what we call enzymes. So hydrolytic enzymes. So the first one is what? Activation hydrolytic enzymes. What else? Apart from that, also activation of leukocytes. So there are two main mechanisms of that. Okay. So the first one is what? Activation of hydrolytic enzymes. Remember that if a cell is undergoing necrosis, it contains what we call enzymes. Enzymes were in the lysosomes. Remember that if you talk about necrosis, the cell membrane is going to be disrupted. Also, the lysosomal membrane there is going to be disrupted. If it is disrupted, it is leaking out enzymes from those lysosomes. Then they'll start what? Eating up the cell. That is it. Hydrolyzing the what? The cell. Okay. So that is the first mechanism. The other mechanism is that also the white blood cells that are like surrounding that cell, they're going to be activated. Okay, and also they will start what? They'll start promoting inflammation, and they'll do what? They'll start eating up the cell, causing what? A viscous what? Liquid like mass. Okay, so what are the two culprits that can cause what? This liquid viscous mass is what? The leukocytes that are surrounding the what? The cell. Okay, and the hydrolytic enzymes that are within the cell. So if the cell, it's the enzyme inside the cell starting eating up the cell, what we call that? We call it autolysis. If the white blood cell from outside or from the extracellular fluid start eating up the cells, then what is that? Heterolysis. Okay. So those are the two processes or mechanisms that can what? Lead to what? Refractive necrosis.